on just the tracks and then just the block groups later. I'm kind of a multitask kind of person, so I'm going to do them both while I've got them both going here. You could do it either way though, but let's do the tracks first, and I'll go to joins and relates, join, and you just follow. You can read through. This is handy the first several times you do these joins to read through each line of this so that you can get used to what it's doing, and think of it as sort of as a big equation that you're building here. And then eventually you'll get used to it, and it'll be a lot quicker. But you're basically joining the attributes from a table. The other option would be a spatial type of join, which is not what we want to do here. And then we need to pick the field that we're going to join on. And in this case, we didn't look at the other data first, but if we had, which is what you would normally want to do, you would find that the STFID field is the common field in both the SF1 data and these Tiger files. So rather than open those up now for the sake of time, I'll just let you take my word for that, and we'll use the STFID. And then we want to use not the block table here, but we want to select the tracked SF1 track table. It's real important to make sure you have the right table joining up to the right polygon layer, or else you'll get some strange results. And so then we're going to choose the field in that table. We're going to join over to this one, and it defaults to the STFID because it sees that's the same. And they are both indeed string fields in this case. But for some reason, notice that the OK button is grayed out down here. So what I found is that if you select this and then just click on STFID once again, then it activates your OK button. So at first I was worried that maybe one was a string and one was numeric, but that's not the case. But that does happen sometimes, and in another video you saw, it pointed out a way you can work around that. If you ever do encounter two fields that you need to join, and one of them is a string and one is numeric, then you can convert the numeric to a string and then do your join. So that's a good background information to have, and I have seen that in this very case with the STFID fields coming from other data sources where they were crossed up and you had to set them to the same. But one of the reasons we're using the Esri files is they're not that way, and it saves us some time, and so we're good to go on this one. We want to keep all the records here so we don't lose any records, and if we do it this way and we see a bunch of blanks in there, then we'll know something's up, that we did something wrong with our join. So then we'll just say OK, and it asks if you want to build an index. Since we're just dealing with one county, I'm going to say no. And then it runs for just a minute and does the join, and doesn't really tell you anything that it did the join. You can open your attribute table back up, and you can verify there that it did indeed do the join. You see we've got our area field, and then everything over to the right is new information that come in from the SF1 data. And that SF1 file contained tracks for the entire state, so there were a number of them, and it went through and pulled just the 8 that we needed for our county out when we did the join by doing it the way we did. And you'll see population 2000, that's going to be the number we want to look at here in a little while. So now let's go ahead and do a join with our blocks as well. Do it the same way, except this time we still pick the STFID, but we want to make sure our table is set to block, which it defaulted to because that was the first one in the list. Joining to the STFID, again, we need to select that though, even though it had by default picked it. That makes our OK button active, and then we can say OK. And we will just deny doing the index again. And it runs a little bit longer this time because it had to join over 2,550 records, which if we open the attribute table, we can verify that we still have 2,550 and that we do indeed have more information, just like we did in the tracks, beginning the next field past the area on over. And we do have population data in there. There's 0 in some of these areas. Some of the blocks were probably in the city areas or something where there wasn't a population counted or something. So, but we have our information. We've got lots of records in there, lots of details, and so we can close that. So now we have a block polygon layer and a track polygon layer, both with the information we need initially. Now, before we move on, the video just continued on from here. One of the things I like to do, I'm not going to do it here, but just to let you know, well, maybe I will go ahead and do it here. This is just my way of, I like to do do this just makes me feel a little more secure about the data. Right now, these fields we created are joined. We have the attribute tables that have been joined from the SF1 data, but it's not a permanent file. In essence, what happens is when we open up our project, ArcMap reads the project file and it sees that we did a join, so it will take each of these polygon layers and rebuild the join every time we open this project. Now that's fine, and normally it works okay, but there are times where you get a lot of layers in there, maybe a lot of joins, and sometimes you'll join more than one table to a given layer. And it's just it's easy for the program and yourself to get confused when you have so many joins. And I like to make a permanent table out of things, because then I know I've got a permanent, I say table, I mean shapefile. You can make this into a permanent shapefile. It is a shapefile, but it doesn't permanently have the population data with it. It's only temporarily joined. And so one of the things you can do is you can just simply right click on each of these layers and go out to data, like we did earlier when we pulled the school data out of our other point data. And we can go to export data, and we can simply we can open up and make sure we're in the folder we want, and we can just give it the name. In this case, we're dealing with blocks. I can call it new blocks and save that and tell it OK, and it will build me a new shapefile. I can tell it to add it to the project, and I then have a new, I can verify that by, you can turn that on and turn this one on. I can look at the records. Remember, we had 2,550 before, and we still have 2,550. If you don't have anything selected, it basically saves and exports everything that you have in that attribute table with that shapefile. If I had only selected certain records, like we did earlier when we selected the schools out of the larger layer, then I could tell it to only export the selected information, and it would give me a new file with just that new information. But one of the advantages of doing this, again, is that we now have a permanent shapefile with permanently all this population information in it. It's not joined. It's not temporary in essence. And if we wanted to join other information to this and things like that, it would be less likely to get confused. Also, if we had forgotten to calculate the area, for example, and we went to calculate the area after we did our join, it would have created yet another temporary field in that table. And then later on, when we did our intersect and so forth, that field would have gotten dropped out of that file, because it seems like ArcMap has a little problem handling more than two types of joins when you're creating a third layer out of that. So at least it did that with me the first time I tried that, just to experiment with it. So that's another reason for making it permanent. If we had forgotten to calculate our area, we could go ahead and do that now while we still have the full range of polygons there that haven't been intersected yet. So let's just go ahead and do that with our tract as well now. We don't have anything selected, so if we go out and export data, it will export basically everything that we have. And we're going to keep it, just to be consistent, we'll keep it in the data source that it's in. But notice we have the option here to export it in the source that the data frame is in, which is kind of nice in a way, because it's almost like doing a reproject on the fly. Though I'm a little more comfortable doing my reprojections in ArcCatalog. So I'm going to keep this in the source data right now. And it's already defaulting to the folder we want. So let's just call this one, we'll call this one new tract. That's what it is. So it thinks a minute and it does the calculation for us. So we can turn off our blocks, and you can verify that we do indeed have new tracks created. So now that we've done that, we can turn off the other ones, or we could even remove them from the project. But for now, I'll just leave them in there. One thing I will do while I'm thinking about this is I'm going to undo my joins. Since I don't need them any longer, since I've made a permanent file, I'll just remove all joins. Notice that only removed all the joins with that one layer though. So if we had done more than one join from multiple tables, that would have removed those. But this one here is still joined together. If we open the attribute table, you can see it's still joined. So let's remove the joins on that layer as well. And again, this is just a little extra step that I like to do, just makes me feel better, because I know I have a permanent file now, and I don't have to worry about anything funny going on if I add more fields to it and forget to calculate acres until later and so forth. And so again, we could remove those others or just leave them in for now either way. But we'll now be working with the new blocks and the new tracks. And the only thing different about them is that they're permanent files, again, with permanently attached to the population data. And they each have an area field in them that we calculated. Now, let me close this out. And I think I pointed out before, but just in case I didn't, notice that one of our schools, the buffers, I'm going to move it to the top here, the buffers of one of our schools goes outside the county a little bit. So this area that we end up with, the results we end up for this was not going to be accurate. Just keep that in mind. The other ones seem to be within the county. For the sake of time, I'm just going to leave this way for now. But ideally, we would either want to drop that school out or get population data, tracks and blocks from the adjacent county, and then join that up with their data as well. So, so let's go ahead now. We've got our joins. We made them permanent. We've got an area field in there. Now we can go ahead and do our intersects. So what we'll do, let's first do the intersect on the tracks. And we'll go up here to geometry, or geoprocessing, I mean. Click on intersect. The first layer we want to pull in is the school buffers. We're basically going to use that school buffer as a cookie cutter, in essence, to cut out the tracks with for just the boundary in that buffer. So now we can pull the tracks over. Now once we've pulled in the two layers that we need to intersect, just to look down below and see if there's anything else we need to change. Most of these we'll let default for now. These are some specialty cases where we could do something a little bit different if we needed to. However, the output feature class, again, it's going to route it over to a file, in this case a geodatabase, over in our temporary folders. So we don't really want the temporary folders, and we don't really even have a geodatabase set up there yet for it to write into. So let's just put it into a shapefile back into our working folder. So if we change our folder, you can see the option down here, defaults to feature classes. And it's defaulted to the folder indeed. So we can just go ahead and just give it a name here. And since we're dealing with tracks, let's just call it I'll just abbreviate it to try to keep my names short, TRT, BUF, INTSCT, for track buffer intersect. Okay, we'll save. And that changes it to a shapefile automatically, which is fine. And it puts it, more importantly, in the folder where we want it. And again, we'll leave these defaults set on everything else. We'll say OK. And it doesn't take it too long to calculate this one. There's not that many polygons involved. But it went through basically and calculated the intersection of our tracks and our buffers for each of the buffers that we have selected. And you'll see there's multiple points, again, around these areas where we have a lot of overlap. So in all likelihood, we don't really have that many schools in these areas, but we were just taking the data for what we had there for this, just to create an example here in this case. So we've got that information. You can open it up if you like and look at the attribute table, and you can see that it has created 437 records. Okay, and it's added a couple new fields here that we're not going to worry about in discussing right now, but these can be important in doing various analyses, and we will probably get into this either later in this class or an exercise for those of you in the 110 class. But it basically assigns information there that can be important. But it's kept all of our other details that we had, and that's important. And we have 437 tracks now that had some portion of their track within the buffer that we created for these schools. So now let's do the same thing. We'll turn that off. Oops, we need the school buffer, turn the track buffer off. And we'll switch from tracks over to blocks. Again, I'm just kind of multitasking and doing these both along the way as we go. You could work one scenario through and then come back and work the other scenario if that makes you more comfortable. So we'll go to selection, and we'll go to geoprocessing and intersect. And again, we'll pull our school buffers over, and then we're going to pull our blocks over. And again, we need to change the path where it wants to sort by default. And just to save some time, I'm going to select this file that we just created and just modify the name a little bit. Instead of TRT, I will save BLK for block, buffer, intersect, save, and OK. It takes it just a little bit longer to run because it's got a lot more polygons it's processing. And once it's finished, if we open up the table there, remember we had 2,550 blocks all together for the county. Now we've got 5,410 that just cross where the school areas are. The reason that number is larger again is because we've got multiple school points that are overlapping each other with their buffers. So for each buffer, it's reselecting those blocks. So now we've got some more information we can work with. And if we start with the tracks, if we turn our track to intersect on, and we just have the tracks and the school buffer selected, then you can see a little bit of the pattern that we've got there. And you can see some cases where there's multiple tracks as evidenced by the boundary lines within some of these. This one is all within one track, it appears. Some of the outskirt ones are all within one track. The inner ones are the ones that are having the multiple tracks. And then again, we've got this one that's got a little outlier from an adjacent county there. So now what we want to do to work this scenario with the population in the tracks is we want to calculate first what area we have now that's in the tracks that's just within these buffer areas. So we want to go back and basically calculate a new area for the tracks, the tracked buffer intersect. So note that we should still have our original area that we calculated in here. And we have to scroll to add a new field. We scroll all the way to the edge and get outside to the edge of the population data. If we really wanted to clean this up, we could either delete or turn off all these other fields that we're not using except for the population 2000. For now, we'll just leave it like it is, and we just want to tack onto the end out here a new field. We'll add a field, and we'll call this one new area, like they did in the video. Change it to double and say OK. And then we want to do the geometry for this area just like we did before. Of course, this time it's going to be smaller because we're just dealing with the buffer areas. And we want to make sure to pick the square miles again so that we're consistent with our units. And we say OK. And this gives us an area that's significantly smaller than what we had before because, again, we're just dealing with pieces of the tracks. And let's do the same thing now while we're doing this for the block buffer intersect. Now we'll just go ahead and make the new field straight out. Call it new area also. Change it to a double. Say OK. And scroll over to the end of the table and select that field. Right click on the header. Calculate geometry. And change it to square miles. And then we've got our area in square miles now in all of those tiny blocks. Or pieces of blocks, I should say, because we've basically intersected that information with our buffers, and so now we don't have a contiguous block, which is why we're doing the next step, because if you notice, if we start with our tracks again, if we go into our track table, we have a new area. In fact, just to see that, I can drag it over if you like. I can click it once and hold my left button down. I can drag it over. Let the table scroll till I find my area field. Go back over to the right a little bit. There it is, and drop it beside it. And you can see kind of see them side by side. You can see they're significantly smaller. So where we had a track that was 123 square miles before, the only part of that particular track that was within the record here for a given school is 12.5 square miles of that. And it's so forth down the table. However, our population numbers have not changed. We still have the full population that went along with that tract to start with. And because of that, it's a little misleading. So these are basically inaccurate right now because we don't have a full tract here that we're dealing with. So what we're going to do is we're going to calculate proportionally the amount or percent of that population that is in this tiny tract in this case. And the way we do that is as follows. So the way we want to go about doing this, let's first clear any selection we made there so we don't, if you have stuff selected and you perform a calculation on your attribute table, it will only perform the calculation for the fields that are, or for the records that are selected. So you have to be careful and make sure that you always have 0 out of something selected when you're doing a calculation, unless you want to do the calculation just on some portion of the database. So we've got our population 2000. So let's create a new field here, and we'll just call it new pop, like they did in the video. We can add 2000 if we like, and make it a double, and say OK. And then what we want to do is select this field, right-click on it, and this time select your field calculator. Now the field calculator lets us, it's a really powerful feature in ArcMap, and it lets you basically write an equation to decide what numbers you're going to put in that field we just created. And what we want to do in this case, like I mentioned before, we can do this in multiple steps, or we can do it all in one step. So let's try it in one step, and I'll walk you through the logic of it. So what we're going to do, we're going to leave the default set in most of these places. We're dealing with a number. We're going to leave it to VBScript, and we want to first select. And notice here it's sort of starting your equation. It's saying new pop 2000 is going to equal, and then what we're going to set that to is, first we're going to take our new area that we created, and let's find the new area, not new pop, and double click that to put it down below. And then we're going to divide that, and we'll click the divide key. We could type these in manually, but I find it's a lot easier to just use the buttons because it does the formatting for you. And we want to divide that by the original area that we had. So let's go nearer the top. I guess it's part way down. And we want to find the first area that we put in here, which can be a little tedious since we have so many fields in there. And there it is. And I will double click that. And so this is going to give us the ratio. So from just that much of the equation, we would know what percent of the area, if we multiply this by 100, we would know what percent of the area we have versus what we had to start with. Now, but with that ratio, what we would do next then is apply that ratio to the total population, because we would want to take that percent of what was the total population to get our new population. But it's convenient because we can do all of this in one equation. So we can take this information, we can now multiply the results of that by the population 2000, which is your full population we had to begin with. Now we can say okay, or you could, if those of you that are mathematically inclined, I guess, might want to go through and put parentheses around these to make sure the calculations are performing right and so forth. But this should work. The equation's going to work from left to right, and so it's going to go through first and do the division, and then it will do the multiplication. And if we were doing a lot of addition, subtraction, and so forth within this and making an even more complicated formula, you would want to go through and put parentheses around these, just like you would in math, calculus or basic math or so forth. But this should work. This again will take the overall area we'll take the new smaller area that we've calculated and divide it by what was the overall area in the original tract file, and then we'll multiply those results by the total population in 2000 to get the new population that just represents this new area that we're working with. So that's what you want to do, and you can say okay, and it will calculate for a minute, and it goes through and puts your numbers in pretty quickly for you. And if you like we did on the area, we can compare those. We can drag this over. I like to do this sometimes just to make sure I'm actually doing what I think I'm doing. Like, for example, you would expect your numbers are definitely going to be smaller, right? Because you're doing a percentage of the population. So if you had done something wrong and for some reason you saw numbers in here that were larger, then you would know you messed up somewhere and you need to go back and find your mistake. Otherwise, you won't know because it's just a calculation. So the program does the calculation as you tell it to do it. And as long as it doesn't violate any mathematical rules, then it is going to give you some result. So you want to make sure that's right, logically speaking. So you would expect that this would be some significantly smaller number in most cases. And it looks like that's the case from what we can see here. So we can now, what we can do, now that we have this information for the tracks, we can go through and basically summarize each school to find out the population that is around that school. So to do that, what we want to do is select the schools so that we can summarize by school name. So we can select that field and right click and click on summarize. And if you read the dialogues here, it kind of walks you through it. Select a field to summarize. We're picking the name, which is the school name. And the only field we want to summarize in this case is the summary of the population. But just for fun, just so that we have another number to look at, first I'm going to include the new population that we calculated, the sum. And let's also include the population 2000, just so we can see how much of that total population got counted. And we'll put that in there. And again, this is just more for fun. We really only needed the new pop was for our answer. And then let's save it to a database here. And it already has the folder selected for us that we want, which is our working folder. And instead of the sum output, let's call it, let's just call it new pop of TRT for tracked, since we're dealing with the tracks here. And we'll say OK. And do we want to add the table to the map? Yes. And now that you'll see what it did is it basically included a database file down here because it's not a shape file. We mainly summarized the attribute table of a shape file to get another attribute table. But in this attribute table, it will have the information that we ultimately wanted at the track level of detail anyway. And so if we open it up, what we have is we have the 34 records, which if you remember, we originally had 34 schools. If I open that up, you can verify that we did have 34. And remember, we numbered the schools since we didn't know the names. And in this table, it's retaining those numbers. We can sort those if we like. And it's already sorted them. And the reason it's jumps from 1 to 10 is because, remember, it's treating it like a string field. So it's counting that 1 before it counts a 2. So remember, and we do have Pleasant Hill in there like we expected. And then the count name is basically telling us how many different pieces of the track polygon were included for each school. It's not necessarily anything of value to us, but if you wanted to do some validation or kind of look closely at your map at the results, you could kind of verify that that was the case. But that's what that's representing, the number of pieces of the tracks once we did our intersect that of the different tracks that went with each school. And then we have the summary of the population, 2000, which is this was our total population that come out of that track field for each one of these, for each one of the school areas. So as you expect, it's a larger number than what we ended up with, which is what you would want to verify. You would expect that number would be larger. And then we have our new population. This is the actual value that we were looking for. So using the tracks as our data source and doing an interpolation, which is we basically did by doing a proportion of the area of that track that lied within a 2-mile radius of that school, then this is the proportion of the total population that we got. So this is our numbers by each school. So school number 1 had 466, you round it to 467 people that live within a 2-mile radius of that school. Now this is based on the tracks. Now we want to go through and do the same thing for the blocks to see what kind of numbers we get when we ultimately do our summarize on the schools. So let's turn our track buffer intersect off, turn the block buffer intersect on, and we'll open up that attribute table. And to save a little time, I've already done the calculation for new area and the new pop, and I've brought them over to where we can kind of compare visually. We can see the new area here side by side, and we've got the population and the new pop here. And you can see we do have some values as we scroll down through there. So we've got 5,410 records. So we've got all of our fields calculated here. So now all that's left to do is do a summarize again, like we did with the track table on this table. And so let me expand the size of this just a little bit. And we're going to summarize on our name field again. So we'll select that column, right click on it, click on summarize. Then let's go ahead and be consistent. We'll summarize both on the population 2000 for the sum and on the new pop 2000 for the sum, just so we can see them side by side. And again, we'll change our name for the table. I'm going to set it to a dbase table, and we'll change it from the new pop track to the new pop block. Let's say BLK to abbreviate. Save and OK. We'll add that table to the map. Now we can do our comparisons. So we've got our two new dbase files here. So let's open both of those up. And that will let us kind of click back and forth to see the results. Ultimately, you want to print these out to lay them side by side and see the differences. But we can do a little bit of that here visually. So you can see in the new pop block, we also have 34 records, one for each school. We'll sort that by ascending like we did the other one. New pop track, and make sure it's sorted by ascending, and it's got 34 records. So when we look at the track as the source for doing our calculations to get an interpolated population value, we end up with, for example, for school 1, we end up with 467 people. If we look at that same school under the block, we end up with only 20 people. So, it's very interesting. You say, well, why is that? And let's look at some of the others, for example. School number 10, using the block as the basis for a 2-mile buffer, we have almost 1,300 people. If we look at school number 10, under the track, we only have 567 people. So it's very interesting that the numbers they're not consistent in one direction or the other. So again, if we compare them, if we look again at, we've got more we found with school number 10, one direction, and less with school number 1, that same direction. In other words, again, if we look at school 1 with the blocks, we've got 19 for school 1, 1298 for school 10. If we look at the tracks, school 1, we've got 466. We've got more on the tracks, and only 567 for school 10. So that's strange in a way. You wonder why that is. And then also another anomaly here is in our tracks, school 10, 11, 12, and 13 all have the same population based on tracks. That's not the case if we look at the blocks. You can see it varies quite a bit. And again, it varies different directions. School 11 is less based on the block, and it's more for school 12 based on the block. So what's going on here? Well, one thing keep in mind is your blocks are a finer level of resolution. So if we look at school, let's keep in mind schools 10, 11, 12, we'll look at some of those schools. If we pick from our table and we just select those schools, let's say 10, 11, 12, and 13, and then we look where they're located, they're all located in this part of the county. If we turn our tracks back on that we started with, you'll see that they all fall within the same track, which explains why they all have the same population, because their diameters are the same. So when we're looking at tracks, and we've got blocks up there, so let's turn the tracks on. When we're looking at tracks, you can see that they contain the same, they're all contiguous within the track, for one thing, all these schools buffers, I mean. And so since they're the same size, they're all going to be the same relative proportion of the total population. So that would explain why it is showing up as 567 for each of those. So, but if we turn the blocks on and turn the tracks off, and in fact, just so we can see a little bit of both, let's do a little manipulating here in our legend. I can't get it to go where I want it to go. No, I need to get back out here to the list by drawing order. And then I can drag my blocks on top, and let's set them to clear color, and let's pick just a reddish outline just to make a point here, and we'll thicken it up just a little bit. And there you can see that we've got a lot more detail, of course, in the blocks than we do the tracks. And if we turn off our buffers for just a moment, or rather the intersects, you can see that detail. If you look around the school, you can see that there's a lot of detail here. Each school has a good fair amount of detail when you're looking at the block level of resolution versus the track level of resolution, see. So that gives us more information to work with. So back to the final point is, which question would you, or which source, the tracks or the blocks, will give you the most accurate answer? It's very likely that it would be the blocks, because the resolution is greater in the blocks, and so therefore your assumptions are a little bit safer, I guess you could say. In other words, with the track, you only have the one population for the whole track to work with. So that population is distributed within that track, and our assumption, again, remember, is that it's distributed evenly. Well, that's not the case. So when we look at our blocks, that verifies that, because we see that there are numerous blocks, and we know that blocks are kind of formed based on an approximate size and area, and so we know that these blocks are going to have different populations in them. So we're getting a finer level of detail when we look at the blocks. In fact, if we zoom in around any one of those schools at the block level of detail, and we look at the radius around that school, I'm just going to set that to clear so you can kind of see the radius a little bit. You can see that it includes numerous blocks within that, whereas it would only include one value for the tracks. So we're getting a greater resolution with our block data than we do our track data, and therefore, in my opinion, you could trust the values that come out of the block data source a lot better than the track data source. And furthermore, if we open those tables back up, remember there's big differences between the two. Actually, we're opening the wrong tables. We've got to go back over to our the list by source and open the new pop track and the new pop block. And so not only would I say that the blocks are more accurate, but there are gross differences between the two. So keep that in mind whenever somebody tells you how many people live within a certain radius of something. Ask them how they calculated that. And a lot of sources are going to be like the video was. They're going to calculate it based on the track, because that's a real common data source, and a lot of people work with track data. So make sure that that when you're asking and answering questions, that you're thinking about the resolution of the data sources that you're working with, and which one's most suited for the problem that you have, and the scale of the problem that you have. We're working in a relatively small area here. If you were running these analyses for a big region of the country or something, for example, then it might make more sense to use the track data, because the processing time and the level of detail, it could just be extreme. You can imagine if one county in Tennessee has 2,500 block polygons. Just imagine how many whole region of the country would have. So again, the block level of detail might be more the better way to go when you're looking at a small area or a county or something like, or a small region, maybe a few counties. And then if you're getting to a state level or even a region of the state, you might want to go with the track level. Because again, if we didn't look at the total sums, but because these errors go one direction or the other, a lot of times they'll statistically tend to balance out. So you'll find that where a block has a higher number than a track, and again in other areas like we saw, it will have a lower number. And if you do this for a lot of areas, statistically that's going to balance out a bit. So that's something else to keep in mind as well. But just wanted to point out that you can get big differences between the two. And if you get just right down to the nitty gritty, the block would be a more precise level of resolution to use, and therefore your answers would be more accurate, I think, from the block source. It's just a matter of how practical it is to use the block level of data. So hopefully all that makes sense. Play around with this a little on your own. Try this, convince yourself of your numbers, and look at some of the fields in there to make sure that you're comfortable with all of this. And hopefully this has been good practice. And we'll see you next time.